Good day everyone. So in today's video we are going to be looking at mole concepts. Now if you don't understand mole concepts, you are definitely going to struggle with almost every calculation in chemistry, and that's one of the reasons why it is the foundation of everything from stoichiometry to gas law, concentration, and even electrolysis. You must understand mole concept completely to have a good understanding of these topics, and that's one of the reasons why it's the first video in this course. One thing I can assure you guys is that at the end of this video you are going to be a pro in mole concept. You'll be able to solve questions even in seconds, so pay attention and make sure you watch to the end. Now let's start. Okay, before we continue, we need to understand what is mole. I'm going to be very fast at it. Now, mole, what is mole? I know most of you have read your textbook definition and many other ones that you got somewhere around, but I want you to forget everything about chemistry now. Let's talk one on one. Now, if you leave chemistry for a while, you understand that there is a word called dozen. Let's start from there. You have a word called dozen. Let's say a dozen of egg, a dozen of eggs. Okay, so a dozen of eggs. So how many eggs? If I ask you that, okay, give me a dozen. Let's say you sell eggs now. Okay, I ask you that I want to get a dozen of eggs. How many eggs are you going to give me? Definitely you are going to give me 12 eggs. So that means a dozen means 12. Without even mentioning the number, you already know it is 12 eggs I'm talking about. You understand? So okay, now okay, let me test you guys on this. Now we know a dozen is 12 eggs. What if I ask you that, okay, I want 2 dozens of egg? How many egg are you going to give me? Yes, you are definitely going to give me 24 eggs. Now I don't need to tell you I need 24 eggs. I just told you I need 12 eggs. I need 2 dozens and give me 24 egg. That means the word dozen is a very powerful word. It helps us to communicate better without mentioning the number of egg or making it ambiguous. For example, let's say I want even more number of eggs. Let's say I want 60 eggs. I will just say I want 5 dozen. It's just like it shortens the number I need to mention. Understand? So instead of saying I want 60 eggs, I just say I want 5 dozen, since 5 dozen is 60 eggs. I hope you understand. So that's basically the idea of mole too. You can also say, if you notice what the characters of the word dozen, it does not refer to egg only. I can use a dozen of shoes. I can use a dozen of shares, and so on and so forth. Understand? So the same way a dozen is, that's the same way we have a word called mole. Sorry, mole. So a mole. Now a mole is not an English word. Understand? You can learn about the etymology, origin, and all of that in your free time, but just know the word mole. The word mole is just like the word dozen, but here it is referring to something else. It is referring to a number of something, just like a dozen, but here it is referring to 6.02 times 10 to the power 23 particles. Now I don't even have to add the word particles. Now I can just say particles or egg or share. The same way I can say a dozen of particle. That means 12 particles. Basically, I can say a dozen of atom. How many atoms am I talking about? 12 atoms. But scientists prefer to use a mole because it's a very big number and particles are very small. So it helps us to tell the number of particles without mentioning. Imagine I'm saying I have 10,555,000 atoms. It sounds weird. So that's basically the reason why we need a word like a mole that has a big number to help us explain atoms with small numbers. Now, how do we come about this number? This number was come about by a man called Avogadro. So that's a very thoughtful person. The man is very thoughtful to come about this number, and let's honor him. Basically, let's name the number after him. He's the one that come about the number. So we call the number Avogadro's number. Though he's not the owner of the number, but at least he came about the number. So let's allow. So Avogadro's number. So it's 6.02. Let me write it very well. Okay, so 6.02 times 10 raised to power 23 particles or egg or share or anything. Understand? It's just a word. A mole means 6.02 times 10 raised to power 23. A dozen means 12. A pair means 2. and so on and so forth. You know the other ones from your English class. So I hope you understand that. Then we call the number Avogadro's number, and we are learning two things. The number was discovered by a scientist called Avogadro, and that's basically why we call the number Avogadro's number. I hope you guys understand. So that's that on that. Now you will notice something. I mentioned the word, instead of using egg and share, I mentioned the word particles. Now most of you wondering what is a particle and why do we use the word particle. Now I'm still going to explain. Okay, so let me explain something to you guys. A mole is just a counting unit, basically. The way we have a pair, the way we have a dozen, a score, and many others for very tiny particles. I told you guys that we use mole for very tiny particles, and that's why you see the word mole most of the time in chemistry, because chemistry deal with very tiny particles. So you see the word mole in chemistry a lot. Counting unit for very tiny particles. So it's just a counting unit for very tiny particles. Like I don't know if you guys know, can we call the tiny particles that we have. We have atoms, molecules, ions. Because these atoms, molecules, and ions are very small and they are difficult to count. I said earlier, imagine saying I have 10,555,200 molecules in this compound. It sounds weird, and that's basically where Avogadro's number comes in. Understand? Imagine saying this number is even big itself, 6.02 times 10 to the power 23 particles. So for every 6.0 times 10 to the power 23 particles, we call it 1 mole. So if we have double of this, we call it 2 mole. If we have triple of it, that's 3 mole. We are still going to learn about that before the end of this video. Now let's focus on what particles are first. So what are particles? UTME and other exam bodies love to set questions for me. They won't ask you what are particles, but I'm going to explain what they will ask you. Now, okay, there is a major formula you need to know. I'm going to write out the formula now. The formula is basically number of mole equals number of particles over Na. This Na is basically Avogadro's number. So if you are with the jotter, kindly jot down this formula now. So number of mole is equal to, no, let me write this out. Number of mole is equal to number of particles over Avogadro's number. So it's very, very straightforward. Now let's take a quick question. Find number of atoms in 4 moles of carbon. Now find number of atoms in 4 moles of carbon. 4 moles of carbon. So how do you solve it? We know we can easily do like this, and we just say n number of, I told you a particle can be an atom. This particle here can be an atom, can be a molecule, can be an ion. So regardless of what they ask you to find, it is still the same thing. So we just say number of atoms is equal to n times our Avogadro's number. So we just say is equal to 4. Our number of mole here, our number of mole here is 4. So 4 times our Avogadro's number, which is 6.02 times 10 to the power 23, which is equal to 24 times 10 to the power 23 is equal to 2.4 times 10 to the power 24. So it's as easy as that. I hope you guys understand. 4 times 6.02 times 10 to the power 23 is equal to 24. 24 times 10 to the power 23 is equal to 2.4 times 10 to the power 24, and that's basically the number of atom of carbon in 4 moles of carbon. Now another easy way you can do it is saying that if 1 mole of carbon is asked 6.02 times 10 to the power 23 atoms, then 4 moles of carbon is going to have how many particles or how many atoms? and you just cross multiply. Then let's say this, instead of putting question mark, let's put x unknown. So we have x mole of carbon of let me just write it as C, of C, x atom. Okay, let me write it this way. Okay, so 1 mole of C times x atom is equal to 4 moles of C times 6.02 times 10 to the power 23 atoms. Now let's cut it out. So it's very easy. Okay, so so x atom is equal to 4. We can, okay, 4 or 1 mole, we have 4 here, we have 4 left here. 4 times 6.02 times 10 to the power 23 atoms. Then x atom equals 24.0 equals 24 times, though we've actually approximated, so that's why you're not seeing the effect of our 0.02. That's 24 times, or let's just be fast about 24 times 10 to the power 23 atoms. Then atoms get to cancel out atom. In chemistry, if you are doing the right thing, your terms is going to be cancelling as long as they are opposite of the equal to sign. So x now is equal to 2.4 times 10 to the power 24. So you can see we got the same simple. Then there's also a reverse case that you can be asked in your exam. Let's say you have, or they ask you that let's say you're asked to find number of atoms in 4 moles of carbon. Then you are going to use formula n is equal to n times Na, then is equal to 4 times 6 times 10 to the power 23 is equal to 24 times 10 to the power 23 is equal to 2.4 times 10 to the power 24. You can see we come about the same number again. Now it's very easy. They ask us to find the number of atoms in 4 moles of carbon. So I will use the formula n is equal to number of particles times Avogadro's number. Do you remember what our n is? Our n is number of particles. Our small n is the number of mole. Please don't mix it up. I wrote it somewhere around here. Okay, this is number of mole, our big N, our small n, our big N. Let me write it here. So our big N is number of particles. Just know small n is equal to big N over Na. This is the formula, guys. So okay, so let's take one more question. Okay, now if you are going to particle, you are going to multiply. Basically, just remember that, because most students find this difficult. If you are going to mole, you are going to divide. So take note of this. If you are converting to particle, you are going to multiply. If you are converting to mole, you are going to divide. Just remember PM, the way you have AM and PM, or MD and PM. So particles we multiply. When we are going to particle, we multiply. When we are going to mole, we divide. So particle can be an atom, a molecule, an ion. I said earlier. So let's say mole is here. This is mole. So you can convert to atom, can convert to molecule, can convert to ion, can convert to compound or formula unit, anything else, etc. You understand? It's just a base, it's just a standard. So you can convert from mole to any other. But if you are converting from mole, if you are moving from mole outward like this, what are you going to do? Remember PM. Understand? If you are going from mole outward, you are going to divide MD. But if you are going from atom, but if you are going from all the particles inside like this, you are going to multiply. Understand? So that way you can solve any question on mole concept very easy. Now let me ask you one question. Convert 5 mole, convert 15 mole, to number of atom very quickly. Convert 15 mole to number. So are you going to multiply it by 6.02 times 10 to the power 23, or you are going to divide it by 6.02 times? Don't remember the formula. I'm no longer using the formula now. Are you going to multiply it by 6.02 times 10 to the power 23, or you are going to divide it by 6.02 times 10 to the power 23? Remember PM. What does it mean? Particles multiply. If you are converting to particles, you are going to multiply. If you are converting, anytime you talk about particles, just remember everything outside mole. You understand? You are going to multiply. If you are converting to mole, you are going to divide. Remember, to particles multiply. So what am I going to do? I'm basically going to do 15 times 6.02 times 10 to the power 23, and whatever I get is my answer. So it's as easy as that when I'm converting out of mole. But if I'm converting to mole, what am I going to say? I'm asked to convert I'm asked how many mole is in let's say, okay, let me look for something we've done here. Okay, if I'm asked that how many mole is in 2.4 times 10 to the power 24 atoms, how many mole is in 2.4 how many mole is in 2.4 times 10 to the power 24 atoms? Now, how many moles are that means I'm converting back to mole. What am I going to do? I told you MD. When you are going to mole, you divide. So you basically divide it by I hope you guys are getting me. So you basically divide by 6.2 times 10 to the power 23. So if you divide this, you are going to have 10 raised to the power 1. If you do this, 10 raised to the power, if you do your indices very well, you're going to have 10 raised to the power 24 divided by 10 raised to the power 23. So you're going to have 10 raised to the power 24 minus 23 is equal to 10 raised to the power 1. So this is what you're going to have times 2.4. Let me put into my calculator. 2.4 divided by 6.02 is 0.398, then times 10 to the power 1. So that's going to give us 0.4 times 10. Then we are going to have 4 moles. So that takes us back to what we have in the initial stage. So it's basically very, very convertible. When you are converting out of mole, what do you do? Remember, PM, you are converting to particles, so you multiply. MD, you are converting to mole, you basically divide. So let's take some few more questions. Okay, so one thing you need to also know is how to calculate molar mass. It's very, very tested in most exams. So let's say you have to calculate the molar mass of C2H6. Now this is very simple. I'm only going to give you one example. Now you have to know the molecular mass of carbon. This is carbon. This is carbon. This is hydrogen. So you know the molecular mass of each of these elements. So what's for carbon? Carbon is 12. So in your exam, you are basically going to be given the molecular mass, so you don't really need to cram it. But it's also better if you know it. Sometimes there might be typo in your exam questions and they might not include this. So just know it. So I'm going to your periodic table, you are going to see the molecular mass of the common. Just learn for the common elements: carbon, hydrogen, basically the first 20 elements. So carbon has a molar mass of 12. So that's 12, and we have 2 carbon here, so that's 12 times 2. Then plus hydrogen has a molecular mass of 1. That's 1 times 6. So when we add these two together, we have 24 plus 6, which is equal to 30. Very easy. So we have 20 grams per mole. So that's how to calculate molar mass. Then let's do one more. Let's say you want to do molar mass for glucose. How are you going to do it? Basically 12 times 6 here plus 1 times 12 plus oxygen is basically 16. So that's 16 times 6. So this is for carbon, this is for, let me write it here. This is for carbon, this is for hydrogen, and this is for oxygen. So 12 times 6 is 72 plus this will give us 12 plus this will give us 96. So the total is going to be 180 grams per mole. 180 grams per mole. So then the second formula you need to know, that's basically how to calculate molecular mass. So we need this to learn the next thing. So I'm going to explain now. So learn this formula very quickly. N is equal to m over m. These formulas are just very simple equations. Number of mole is equal to mass over molar mass. Now, when you know this and you know how to convert, you know how to calculate your molar mass, it becomes very easy. Now, first question: convert 34 grams of NH3 to moles. If you have to calculate 34 grams of NH3 to moles, first thing you need to know is that you have to calculate the molar mass of this. Whenever you are giving gram, always look for the molar mass first if you want to convert to mole because of this formula. Now, let me quickly highlight the so this is the mass, this is molar mass, and this is number of mole. So you can see the number of mole we have here, we have in this formula. What is the first formula I gave you guys? So N, yes, this first formula I gave you guys. This number of mole here, number of mole here, we also have it here. We also have it here. So number of mole is also equal to mass over molar mass. So let's say you have to convert 34 grams of NH3 to moles. First, you have to find the molar mass of NH3. How do you find the molar mass of NH3? You have to know the molar mass of the mass of 1 mole of nitrogen. So that's basically 14. You are going to be given in your exam, so you don't have to worry about that. So nitrogen is 14. That's going to give me something like this. Then hydrogen is 1. So you get something like this under each of your questions. So now, to find the molar mass of NH3, so that's going to be 14 plus, since we just have only one of nitrogen, so we don't need to include anything. So molecular mass for hydrogen is 1, then times number of hydrogen that we have, that's 3. So that means we have 14 plus 3, we have 17 grams per mole. So what this tells us is that for every 17 gram of ammonia you take, you are going to have 1 mole inside. That means you are going to have 6.2 times 10 to the power 23 molecules of NH3 inside for every 17 gram of carbon of ammonia that you take. Now let me ask a question. This is just a random question. What if someone does not take 17 grams? What if someone takes 34 grams of ammonia? How many moles of ammonia molecule is going to be there? Basically, that's double of what would have if you took 17 grams. So that means we're going to be having 2 moles. It's very easy. 17 is just 34 is just 17 times 2. So if we double the amount of grams we get, we also have to double the amount of moles we get. The easiest way to do it to say if 17 grams is equal to 1 mole, then 34 grams will be equal to how many moles? Or let's say x mole, then equals multiply. Then you say 17x is equal to 34 grams. Then you're going to 17, then you're going to say x moles. So this is another method. Let's use the formula method. If you want to use formula method, it's very easy also. Just use the formula. Just say N equals mole equals mass, number of mole equals mass, same thing, over molar mass. So number of mole equals to the mass, 34 grams, over the molar mass. What's our molar mass? Our molar mass that we calculated here was 17 grams per mole. So what is number of mole? So our number of mole is per mole. So that's just it. So for the number of moles of NH3 in 34 grams of NH3 is basically 2. So we have 2 moles in every 34 grams of NH3. So that's basically it. Now you see this method that we still got the same thing. We are just telling that if you have 17 grams in 1 mole, then 34 grams is going to be in how many mole. Then I don't want to decide which one is faster. Okay, me, I love this method because I don't need to use the formula. But if you want to use, you can see most of the questions I'll be solving I'm using the 2 methods. The formula method. This one with formula is very straightforward. This one without formula is technical, but it's very easy to do, to be depending on you. Now, what if you are asked to convert, let's say, 3 moles of neon to grams? Okay, 3 moles of neon to grams. Then remember that Ne is equal to 20 grams per mole. This is the molecular mass of neon. So just use the formula straightforward. M mass equals n times m. But just simply cross multiplying, since n equals m over m, if we cross multiply here, we can say m equals n times big M. So that's the number of mole times the molar mass. So this is equal to the mass, the number of mole, 3 mole, times the molar mass. What's the molar mass? 20. It's equal to 60 grams. So this is basically the answer. So the same thing I explained to you guys when we were doing mole to particles. Note that when you are going from grams to mole, you divide. When you are going from moles to gram, what do? You multiply. So if you are confused about how to use this formula, just know that when you are going from grams to mole, you divide most of the time. When you are going from moles to gram, you multiply. So just know how to use the formula. Basically, that was the easiest way for you. Now, the third formula we are going to be looking at is gas volume. Is gas volume. Then this one is very straightforward. Just know that 1 mole of gas is equal to 22.4 dm cube. So the formula is very straightforward. Number of mole is equal to V over 22.4. Now note that this 22.4 is only valid at STP. Let me write it out for you guys. STP. Sorry. STP. STP is same thing for standard temperature and pressure. So in your exam, you are going to be giving that at STP. Whatever they are giving, whatever the question is, they write at STP in most chemistry exams, so you don't have to worry. Once you say at STP, that means it's mostly related to volume, and they want you to use the standard 22.4. So those are 1 mole of gas equals to 22.4 dm cube. So let's take one question now. The question says 12 grams of helium. Convert it to number of atoms. Or let's take this one first. Find the number of moles in 44.8 dm cube of gas. Okay, so this is the question. The question is very straightforward. Find number of mole in 44.8 dm cube. Now let me use the first method. Now if 1 mole, if this is just conditional statement, is equal to 22.4 dm cube, then how many mole will be equal to 44.8 dm cube? Just cross multiply. We just see 22.4 times x. Let's say this is our x, is equal to 44.8 times 1. So let's multiply by 22.4 by 22.4. Then we get x is equal to 2. So that means we have 2 moles in 44.8 dm cube of gas. Now it's very easy now that it is just a double of it. Sometimes it might not be double. You might be having very, very weird values like 1.07, 0.10. But this is basically just the basics. If you understand this, you can do any value they give you. Now the second method is the formula method. When we have number of mole is equal to V over 22.4. So what we have to find? We have to find number of mole. That means our N is equal to, what's the volume? 44.8 over what is value here? 22.4. Note this must be at STP. When it's not at STP, it's definitely something else. Understand? But for most of the questions you'll be seeing on mole concept, you're going to see at STP. If it's not at STP, that's definitely a different topic. But once you're at STP, just know that this formula you're supposed to use. So when you calculate this, you have your N equals to, that means the number of mole is basically equal to, easy. Now what if they combine the 3 formula I've given you guys today together? I'm going to be explaining how it works. Now what we have, since we say N is equal to mass over molar mass, we also say N is equal to volume over 22.4. Now this 22.4 is basically molar volume. So if you see molar volume or is 22.4, don't think it's a mistake. So V over molar volume. Now note it's 22.4 dm cube, not meter cube or any other thing. And please note, or 22 0.4 liters. Let me write this out because sometimes you might not see dm cube, you might see liters. Liters is the same thing as dm cube. Please take note of that. Liters is the same thing as dm cube, but you might see then you might also see 22,400 centimeter cube. Understand? So yes, centimeter cube. That's basically them converting dm cube to centimeter cube. So it's almost the same thing. So please take note of that. Now, okay. So then the third formula I give you guys. I told you guys are n over na. This is Avogadro's number. This is number of particles. I told you can be atom, mole, or anything. Now let's combine these three formulas. Since n is a common factor, we say mass over molar mass can be equal to volume over molar volume can be equal to number of particles over Avogadro's number. So this is the combined form of the three formulas. Now let's solve a question with something like, now you don't have to use the three at the same time. You can just pick two like this. You can pick two like this. You can even pick this one and this one like that, and solve your questions. So it makes your work easier. So what if you are asked to solve this question? 12 grams of helium to number of atoms. Now what are you going to do? Just know that the first step is to know that n is equal to mass over molar mass. So that will be equal to what? It's going to be equal to, what is the mass? 12 grams. So the mass is 12 grams. So 12 over, what is our molar mass? Our molar mass for helium is 4. I told you guys earlier, you need to convert that from your periodic table. If you don't know it instant, you can decide to memorize it, or most of the time they're going to give you in your exam. So okay, 12 over 4. Then we have 3 moles. Now we are not asked to calculate the number of moles, we are asked to calculate the number of atoms. So we need to calculate the number of atoms now. So then this step 1, then this step 2. So n now is equal to 3 times 6 times 10 to the power 23 is equal to 1.8 times 10 to the power 24. Remember, we are converting now from mole to particle. So what are we going to do? Remember, pm. So 3 times 6 times 10 to the power 23 is equal to 1.8 times 10 to the power 24. So I hope you guys understand. So it's very straightforward. We just multiply it. So if we are converting to particle, we multiply. So that's basically that on that. Then we can always move like this, maybe from grams to moles to particles, or from even particles to moles to grams, and all of that. You can easily switch from volume and all of that. Once you know how to use these your formulas and you know when to multiply, when to divide, you are not going to have any problem. So that's basically that on that. So remember the three formulas I gave you. I gave you the first formula, n is equal to m over m, 1. Then 2 is n is equal to n over na. Then the third one is n is equal to v over 22.4. So those are the three formulas I gave you guys. And you can now easily convert from mass to mole and to particles, and from volume to moles to particles, and all of that. So with this, you've covered 70% of chemistry calculation. This is the basics. You can see this video took our time. This is because we are dealing with the basics and we need to do it diligently. Now in the next video we'll be looking at probably stoichiometry, but for now we've mastered mole concept. So don't forget your Avogadro's number. I hope you guys still remember your Avogadro's number, 6.02 times 10 to the power 23. So please take note of this number. It is very, very important. So if you learned something from this video, if you liked it, click on the like button, and if you don't mind, you can subscribe to the channel. It's not a must, but if you don't mind, you can subscribe to the channel. And if you like the video, click on the like button. Thank you very much for your time.